Hello again, everyone, and thanks for joining us for another particular live webinar. This is William, and today I'm joined by my colleague and solution architect, Mauro Servienti, who's going to be talking about Got the Time. Just a quick note before we begin, please use the Q&A feature to ask any questions you may have during today's live webinar, and we'll be sure to address them at the end of the presentation. We'll follow up offline to answer all the questions we won't be able to answer during the live webinar. We're also recording the webinar, and everyone will receive a link to the recording via email. Okay, let's talk about time. Mauro, welcome.
Thank you very much, William, and welcome everybody. And let me start by saying that I'm always amazed by the way my colleagues pronounce my last name. As you may guess by my accent, I'm Italian and my last name is quite complex to pronounce, but they are always wonderful in doing that. So welcome again, and let's talk about time and how it affects the design of our systems. More or less 25 years ago, in an era without Facebook, no devices, very little technology, and if you were there, and you are as old as I am now, you might remember that there were mobile phones, but there were those strange things with buttons and very little screens. And at that time, my girlfriend and we bought tickets for a theater show. And we put those tickets on a board like this one. This is my actual a picture from a board in my current kitchen. And then we forgot about the show. We never went to the show. Why? Because there was no reminder at all. So we bought the tickets probably a couple of months in advance, and then it got out of our minds, and that was it. And we remembered it a few days after we were expected to show up for the show, and we regretted it, but there was nothing we could have done about it. Roughly at the same time, I was working for an accounting, I was working in an accounting department for a manufacturing company. It was the very beginning of my career. And in that accounting department, one of the things we were regularly doing, we had to check for overdue invoices. So essentially, at the 10th of every month, we were checking for the invoices issued the month before, checking if they were paid or not. At the time, the company was essentially issuing invoices just at the end of the month. Well, it was issuing invoices every day, but the payment was a month after the end of the month of the invoice. So essentially, if the invoice was issued on the 20th of the month, the invoice was due the end of the next month. So it was easy for the accounting department to simply sit down and do what we can call now a manual batch job. So essentially, we were sitting down, checking invoices, a lot of sheets of paper, and going through one by one and checking the amount of the invoice with the account statement from the bank. And that was the only option back then. There was very little technology to do that. All of a sudden, well, not really all of a sudden, but at a certain point, the business evolved, and they made the decision to change the invoicing processes. And instead of having invoices all expiring at the same time at the end of the month, the invoice was set to expire the 30, 60, 90, whatever number of days after the date the invoice was issued. That caused a sort of a flood of invoices. So what happened is that from the accounting department perspective, we found ourselves all of a sudden too busy. So we were spending days checking for overdue invoices. The batch job concept, that was a human batch job thing at the time, was essentially killing the business from the accounting department perspective, because every day we were sitting there checking for overdue invoices and trying to match them with bank account statements with all sorts of issues. Because one of the problems we had was, for example, is the bank account statement up to date? So, for example, one of the problems you might have is that if the payment is coming from a different bank, there are a few days that the bank takes to deliver the money. And so you might see that, well, the invoice is due today, they have paid, but we are not seeing yet the amount of the payment on the bank account statement. So we have to schedule this invoice to be checked again in a few days. So it was put aside and added to the sort of the next batch job. And even the simple question of are there any invoices due today was complex to answer, because the only option for us was really to go through all the issued invoices and check the date and say, is it due today or not? Is it overdue? And stuff like that. So essentially, we were busy doing just that the entire day. And if we look at that from the architectural or the system design perspective, the question we should really start asking ourselves is, what are we looking for? If we put ourselves in the shoes of that accounting department, what was the accounting department looking for? Were we looking for an overdue invoices report or something more straightforward, like an alert when an invoice is overdue? And by the way, a collateral report. So if we have alerts, then we can list all the alerts, store them, and say, okay, now we know what are all the invoices, which are all the invoices that are overdue and unpaid. And obviously, if you ask this kind of question, then the only answer you can get is that we want alerts. It's clear that we don't care about reports from that specific job's perspective, but we just wanted alerts. We wanted to be notified that, well, the theater show is happening tonight, so you better show up, or this invoice is overdue, you better check why it's not paid yet. That was the primary goal, not spending hours going through the list of overdue, of issued invoices. The next question we should be asking then is, what's an invoice? And it's very easy to say that an invoice is a sort of set in stone thing that doesn't really change, because that's untrue in the end. If you look deeper, an invoice is essentially an aggregate with state and behaviors. So because we can look at an invoice from the behavior perspective, and we can model an invoice like if it is a state machine. So we can say an invoice is in a status which we can call draft created, an invoice is issued, an invoice is paid, an invoice is overdue, an invoice for an invoice has been issued a credit note, or there might be things like partial payments and so on, or an invoice has been reissued and the payment date changed and stuff like that. So there are many, many different behaviors that might change the state of the invoice and even the content of the invoice itself. Well, from the accounting perspective, the invoice doesn't change, because if we know that if we're going to for example, reissue an invoice, the invoice number will change. But conceptually, it's the same payment that we're changing, right? So if we have state and behaviors, then we can start looking at invoices instead of like if they were just documents, from the perspective of behavior modeling, and say, well, if we're modeling behaviors, that means that we have some sort of a trigger that comes in. And then we have a state manipulation that happens, and let's say events out or messages out, whatever messages means in this context. We're not talking about messages on a queue yet. So and even the trigger could be an HTTP request. Doesn't really mean that it needs to be a message at this point. So let's view this triggering state manipulation events out from a visual perspective. So we have an issue invoice sort of command that asks the system to issue an invoice. The system reacts saying an invoice has been issued. And then what we need to do from the accounting department perspective is that we want to know when the invoice is due. So we want to be alerted in some way about the fact that an invoice was supposed to be due today. Is it paid or not? And then when that happens, we want to check for the payment. So the question now is, how do we do that? Because if we try to implement the same way we implemented the manual batch job process, we'll end up overloading the system no matter what. Because imagine that. So let's imagine implementing that using a batch job. You'll end up having a sort of recurring batch job that runs at least every 24 hours and check for all issued invoices and try to match them with the information that the data that says is it paid or not. And that's the only option you have. And if there are no invoices issued for that are expired, that are expected to be due today, then you end up overloading loading the system for no good reasons. So when it comes to modeling this kind of behaviors, so you have a trigger that comes in, a state manipulation, and an event, one very good fit are messages and sagas. They really help in modeling this. So how does it work? So let's start by, I assume everyone knows what a message is. So in this case, a message is something on a queue. So it's a message sitting on a queue. So it's the, for example, the issue invoice command that we saw before. And we have this message on a queue that, and then we have a bus and as a concept and a persister as a concept. So the bus is the thing that takes care of handling messages, and the persister is the thing that takes care of saving, storing, and loading the state that we just manipulated. So for example, one thing you can do is that we have a saga that is the thing that coordinates these messages and allows the messages to manipulate a specific state. So we have a message coming in that goes to a saga, in this case, for example, creates a saga. The message is then dispatched and the state gets manipulated. The saga might send messages, as in, for example, publishing events. So we have a trigger that comes in, a state manipulation that happens, and the message, one or more messages that go out. And finally, we have a state persistence, so that the state is persisted in a storage, and a follow-up message can hit the same state and proceed with the manipulation. So for example, there's a new message coming in. At this point, the message is for the same saga that we touched before. So the saga state is retrieved from the storage and the message is dispatched. The state manipulation happens. If the saga is completed, it gets stored and it gets deleted, or maybe there are more messages that happen. So as the saga publishes another message and so on. And it can go on essentially forever. Now that we have a better understanding of, from the high level perspective about what a saga is, let's try to implement what we just talked about. So an alerting system that allows us to understand that an invoice is overdue using messages and sagas. And let's do that looking at the code immediately, and then we'll dive into the code details. So I noticed from the poll that not everyone is used to .NET development. The code is very, very simple. There might be things that are strange if you're not used to .NET and C#, but I guess that everything is understandable. And if you have any questions, just drop it in the Q&A feature of the Zoom webinar. So what do we have here? We have some code that handles a message. And that's the trigger message, right? So we have an incoming message. In this case is, for example, the invoice issued event. So when the invoice is issued, we want to know when the invoice is expected to be due. So what we do is we store into the state the invoice number. That's the state manipulation thing. Then we retrieve the due date. And if it's an Italian customer, we just add a bunch of days just to be safe, you know, Italians. I know my chickens, we used to say. And then we schedule a delayed delivery. What's delayed delivery? It's a message for ourselves in the future. And we're using the due date as the date for a message, for the message to expire. What expires means in this case? It means that the message will be delivered to the saga when the due date is due. So essentially, the message, if it's an Italian customer, will be delivered 20 days after the due date of the invoice. And the message that will be delivered is the check payment message. The important stuff here is that there will be a shared transaction, and transaction is quoted because it's not necessarily an ACID transaction, depending on the storage type or the queuing system you're using. Technical details, and there's a bunch of documentation about that if you're really curious. In between the state manipulation and the delivery of a message, Why you want to share the transaction? Because you don't want to end up in a situation where you have manipulated the state and never published any message, or the other way around too. You don't want to have published messages with no state manipulation happening. It means that you'll end up in a sort of corrupted system scenario, and we want to avoid that as much as we can. What happens when the message expires? So when that request timeout comes to the date represented by the due date, here is the code for that. So we want to handle the timeout. There is a message like any other on a queue. That message is delivered to the saga, as in the diagram that we showed before. And when that happens, what we do is that we say to the world, by publishing an event, invoice overdue, invoice number. So what we're doing is retrieving from the manipulated state, the invoice number, and we're using that invoice number as the value for the event we're going to publish. And finally, we're self-deleting ourselves. So we're marking ourselves as completed. And again, we want to have a shared transaction here. So we want to make sure that if the event is published, we're going to delete ourselves. If we're going to delete ourselves, the event is published. Otherwise, again, corrupted state scenario, and we don't want that. But hold on. So you're telling me that whenever the message check payment comes in, we're checking nothing. So if you look at the code here, the code is straightforward. It does no check. It doesn't really check if the invoice was paid or not. It assumes that if this check payment message comes in, the invoice is overdue. How's that? Well, that's interesting, right? Since we have a saga that represents this state machine, and I'm saying state machine in quotes because it's not really a state machine. It can be seen as a state machine. So given that we have that, we might have multiple triggers hitting the same saga, causing different behaviors. So one other trigger could be this one. So we have an invoice paid message that comes in. And the only thing that we do when the invoice paid message comes in is that we mark ourselves as complete. And what happens when we do that? The saga is deleted. So essentially what we're doing is we're taking the simplest path to solve the problem. We're saying we issue an invoice. Let's say that the invoice is due in 30 days. In 29 days, the customer pays. The invoice paid message comes in. The saga is marked as complete, which means that the saga is completed. But we have a timeout in the queuing system that will expire. The timeout expires the day after. NServiceBus handles the timeout, looks for a saga. It doesn't exist, so it considers the message handled. Because if the saga was marked as completed, there's no need to dispatch any timeout. All the expired timeouts for a completed saga are essentially useless. So we don't need to check if the message that represents the timeout comes in. We don't need to check if the invoice is overdue and is not paid, because that's by definition. Because if it was paid, the saga would have been deleted. So let's go back to our diagram for a second. So what we can now do is essentially shortcut and remove the when due. So because the check payment message is a timeout, that is what we call a delayed delivery. So essentially, as we said, it's a message that is sent back to the queuing system, and we kindly ask the queuing system to, can you deliver this back to us in a few minutes, a few days, a few months, doesn't really matter. We can set that. And depending on the queuing system you're using, it might be a built-in feature. So for example, in Azure ServiceBus natively supports delayed deliveries, or in RabbitMQ, we built that on top of RabbitMQ. In SQS on AWS, we built that on top of SQS. But anyway, the feature is transparently supported on any transport that we support. So what the interesting bit I want to spend a few minutes talking about here is that, what did we do? We built the alerting system, if you think about it. So if you look at this from the perspective of the accounting department, we can now stop looking at issued invoices. The system will notify us when one of the issued invoices is not paid. That's the same thing as buying theater shows tickets and forget about them, because someone, today my phone, will probably remember me a few hours early before the event. You'll have to go to that event, right? That's the same behavior, essentially. We're buying tickets, we're setting in the calendar a timeout or a reminder for ourselves that at a certain date and time will trigger and will tell us something is going to happen. Or in this case, something has happened, the invoice is overdue and not paid. Let's have a look at a little bit more complex scenario. Let's say that you have an e-commerce system, whatever, something, you're selling something to someone, and then you want to introduce the concept of a premium customer. And, excuse me, what premium customers get is that if their monthly running total is above a certain threshold, in this sample, $300, they get a 10% discount. So let's dissect a little bit the requirements. It's not that if your last order has been more than $300, is if in the last month, the total of orders you placed and you add up them, it's more than $300, then you get a 10% discount. As soon as it's a sort of a sliding window, right? So as soon as that amount goes below $300, you're not a premium customer anymore. If you go above $300, you're again a premium customer, and so on. So a very naive approach to implement this would be something like this. Let's say that we're placing an order and then we want to calculate the discount and we have the customer ID, right? So what's the last month is date time now, add month -1. So we go back in time by 30 days or 31 days, depending on the month. And it doesn't compile because it's missing a dot. Anyway, and then we do a sort of a query. In this case, the query is expressed using link, but that doesn't really matter. So we're querying orders on the database. That db.orders is the database table for people not used to link queries. And then we're saying where the customer ID is the customer ID that comes into the method, and where the order timestamp is greater than last month. And then we're summing, we're adding up all the amounts. If the last month total is greater than $300, then you get 10% discount. Otherwise, no, you don't, right? Sounds easy, like so. And despite the fact that we're hitting the database for every single order that gets out, it works some way. However, the business comes in and it evolves again. Those stakeholders should really stop doing what they do, but anyway. And what the business says is that we want to introduce corporate accounts. So instead of having your own user account in the system, now you have a sort of a business account and multiple sub-accounts that can buy. And the policy, the premium customer policy applies to the business account. So if I'm a private account, not a business one, then I'm a singleton account, which means that all my the orders that apply to the policy, the policies apply to are the orders I placed. If I'm a business account, all the sub-accounts can place orders, and whenever one of them places order, all the orders placed by all the sub-accounts in the business account concept should be evaluated for the premium customer policy. So what happens then? That all of a sudden concurrency becomes a problem. So let's say that order is placed for business customer 123 by account A, right? By sub-account A, and the total amount is $100. The discount is calculated, running total is 250. So let's say that is less than 300. So no discount is applied. Concurrently, what happens is that for the same business account, someone places an order for $60. discount is calculated, running total is still 250, so it's still less than $300, and no discount again. Ha! And that's wrong, right? Because the second one should have got the discount, because the first one placed an order for $100. What's happening here? Concurrency kicks in and creates or causes stale rates or ghost rates. So what's happening is that this query is reading data that are not updated. So what comes back from this query is the wrong amount. What's a very naive approach to concurrency in this case, and a terrible one, sorry about that, but we can create a transaction, and the transaction must have a serializable level. And then we can open the connection to the database, set the database to use that transaction, run the same query, commit the transaction, and boom, deadlock. So as soon as the system gets some load, essentially the pessimistic locking approach will cause deadlocks, because we'll end up opening serializable transactions and queuing up requests for the same business account, waiting for the concurrent order that just came in a microsecond before the second one to be completed, and then again and again and again and again. And the problem obviously is exacerbated by things like the Black Friday. So as soon as you try super overloading the system, then you'll be, there's no way you can survive using a concurrency, using a pessimistic locking approach to concurrency. One option again is batch jobs. That sounds like something viable, right? So what can we do? We can run a batch job on a schedule, run over all customers, sum all the orders amount for the last 30 days for all customers, business customers and non-business customers in this case. If the policy is matched, create a discount coupon. So the batch job is responsible for creating discount coupon, which first is not really what the requirement was, because the discount coupon will be applied to the next order, not the one that is currently running. So if we're placing an order now, and we're already above the threshold of $300, but the batch job hasn't run yet, we don't have the coupon, and we'll end up paying the total amount and not getting the discount, even if that's not correct, right? And again, good luck running the batch job during a Black Friday, because the system is already overloaded, and the batch job will overload that even more, which is not really what we're looking for, right? So, and then discount coupons are generated only when and if the batch job runs. And that's an important problem, right? So if something goes badly with the batch job, then we'll end up violating the policy even more, simply because we're unable to run the batch job, which in the case of overdue invoices might not really be a big deal, right? Because we can say, okay, we'll check for overdue invoices tomorrow. Who cares, right? It's not really a big problem. But in this case, customers might complain because they say, well, my total amount was above $300. Why didn't I get a discount? Oh, sorry, because our batch job approach failed. So let's have a look again at the timeline, because it seems that, again, there's a time component here. And it's clear from the fact that we have a sliding window, right? So we have a total amount of orders that is moving as time moves. And let's try to kill the batch job. Again, we have the same behavior as before. So we have trigger in, placing order, some state manipulation, the creation of the order, and something else probably, and then again, events out. Let's view it. It's a little bit more complex than the one before. So we're placing an order, and maybe the system raises an event that we can call order placed. And when the order has been placed, we want to calculate the discount. And at the same time, we want to add the total amount of the order to the running total for that specific user or business user. And only once those two things are done, we want to process the order. And then what we want to do, again, applying the logic that we applied for overdue invoices, we want to schedule a message for ourselves to deduct from the running total within 30 days. That's interesting, right? So instead of trying to calculate every single time what's the total amount for a specific customers, we are simply adding and removing values, so order totals, from a running total. Let's view it from the arrow of time perspective, because it's probably simpler to understand what's going on. At T0, we have the user interacting with the system and placing the order. Fine. At T1, we have the things that happen, calculate the discount, process the order, and add that to the running total. At T1 plus 30 days, we deduct from the running total using a timeout. So essentially what's happening is that for every, if you think about it, for every user that exists in the system, there will be a never-ending saga that keeps track of the running total for that user. That when it starts is at 0 and might be at 0 until the first order is placed. When the first order is placed, the saga keeps track of that order amount. After 30 days, it deducts from the running total that order amount. So it might go back to 0. Or if another order was placed in the meantime, it calculates that. Let's have a look at the code again. So whenever we place an order, we have the trigger message that is order placed. And then we manipulate the state. So we say, okay, let's add to the monthly running total, the total order amount for this user, because the saga is now bundled to the user. And then we can say, okay, process order, where order ID is the order ID that came in with the order placed message, and the discount is the discount that we calculated at the first line when we calculated the monthly running total based on the current monthly running total. And then finally, we request a timeout. And in the timeout message that we're sending out, we're setting the order total amount we want to be deducted in a month, right? So, and again, as before, we want these three things to happen in a transaction, because otherwise we'll end up in a corrupted system. And when the message expires, so in 30 days, what we'll simply do is that we deduct. So 30 days later, we deduct from the system the order amount of the total amount of the order for which the deduct from running total message was scheduled. We don't really care what the order was, except maybe for logging purposes. But from the saga perspective, the only thing that we need is how much money should I deduct from the monthly running total. What happens in this case then if there's a concurrency? So let's imagine now that it's the Black Friday, or we have concurrent orders for the same business account. Let's view it from the graphical perspective, because it's easier to understand what's going on. So now we have two sagas, right? So what's happening is that a message comes in for the saga on the left, and another message is handled and is handled by a saga on the right. Why can this be? For example, one reason might be that the saga on the left is triggered by the user A for business account 123, and the saga on the right is triggered by user B for business account 123. But it's the same saga instance, right? Because it's the saga for the business account 123. But given that there are two concurrent orders, there are two messages handled concurrently. And so the two saga instances are hit at the same time. They are loaded from the storage. The message is delivered to the saga, and then both will try to persist using the business ID 1337 in this case, or in the sample that we had 123. One of them will fail, and in the simplest case will fail because of concurrency control. So an optimistic concurrency exception will be raised by the storage because someone else already touched the same record before. So the second one, the one on the right, is trying to save some stale data. And the message for the second one is retried, and what's happening is that now it gets the right amount. So we're not anymore in the case of having a wrong total amount calculated by the system and not issuing a discount specifically for that specific order, because when the message is retried, it's simply delayed a little bit, but the data are not stale anymore. And we're not using any transaction, any pessimistic locking in an attempt to lock the data and then overloading the system even more. So what are the takeaways that we can take away from what we learned so far? Is that the first thing is that we want to try to avoid as much as we can the technical solution trap. So it's very easy to say, we have a list of things we need to check. Let's apply a batch job, or let's apply a batch job kind of mindset to the problem and go through that and essentially end up with a batch job. The other thing we want to do is really understand the real business needs. Because one of the problems we have with domain users or business users is that they come with solutions, right? They will come and say, we want to have a list of not paid invoices. That's not really what they want. They want alerts for unpaid invoices, or they want to be able to apply discounts to specific orders. And the fact that they are coming with a sort of pre-built solution, because maybe that's the way they've ever done that, or from the beginning of time, they were doing that in that way, doesn't really mean that it's the way we should implement that. So be mindful about that and do not fall into the trap of listening too much to them. Try to better understand what's the real business problem behind that. And then the third one is that we want to be able to model time by sending messages to our future selves. So one of the things that we have when we're dealing with time is that we can model time by using delayed deliveries and make so that something that should happen in the future or something that we expect to happen in the future will happen, or we will be able to react if something doesn't happen. Let me give you a sample about that. So let's imagine that your system needs to ship goods, right? You're selling stuff online and you need to ship them. And then shipping is done using a third-party provider, FedEx, right? So your system tries to use the FedEx HTTP API to schedule a pickup. So I buy something in the system, and then your system pings the HTTP API by FedEx, schedule the pickup. Now, how does the system react to the fact that no one is showing up? That's a timeout, right? So what the system can do is hit the FedEx API and then schedule a timeout for itself, let's say 5 hours later, the expected time for the delivery courier to show up. And if the delivery courier shows up, a message will come in saying shipment picked up, which will complete the delivery saga, and then the timeout will be ignored. If the delivery courier doesn't show up, then the timeout will be handled, and it means that we have a problem. And now we need to escalate the problem. But we have a message coming in that is again a trigger, and we can use that message to manipulate the state again, and maybe send a message to Mauro saying your delivery will be late, and then raising an event internally to speed up things and try to understand how to overcome the problem. So we can model everything that is related to time using delayed deliveries. And these are the three main important takeaways I'd like for you to take away today. And I'd like to thank everyone for having joined me and my colleagues today. My name is Mauro Servienti, as William said. I work for Particular Software. There are a few contacts. You can ping me. And thank you very much. Demos are available at the first link. Slides I used for the presentation already available at the second one, and a tutorial about using timeouts within NServiceBus sagas is available at the third link. And I think that there are a few questions. There's a question from Philip. How is a saga different from an aggregate? Under the hood, it's not. There's implementing aggregates using sagas is a very good way of implementing aggregates in a distributed system. One could argue that aggregates and distributed systems don't fit really well, but if we want to implement some domain-driven design patterns when building distributed systems, sagas are a perfect fit for that. One of the quote-unquote side effects of using sagas is that they force us to go through some CQRS kind of approach, because there's no easy way, because we built that intentionally in that way, to read the saga state from the saga storage. So there are ways to do that, but we try to avoid that, because the saga state is private to the NServiceBus implementation, technically speaking. So we advise customer, we warn customer that it should not be done. So what the saga can do is essentially publish events that can be used by the system to build up read models that representing the current state of the saga for a UI, for example. Then there's a question from Michael. What are your suggestions, thoughts on how to integration test, validate these saga timeouts in a testing environment? That's a very interesting one. So the NServiceBus framework comes with a testing API. So, and it allows you to build unit tests for sagas. So sagas are just a class like any other. So there are no special requirements for a saga. And then you can unit test that saga. And given that messages are just classes, you can mock messages, mock sagas if really needed, or just create instances of those and then exercise the saga itself. It's tricky though, because the unit test doesn't take into account the real system. So the unit test runs in memory, so there will be no queuing system. And what happens if the endpoint that is hosting the saga is, for example, misconfigured? Or what happens if a timeout gets delivered somewhere else? I'm just inventing something. So what do we have? There are integration options as open source projects. One of them I wrote it. Another one is written by Jimmy Bogart, that allows you to host the real production saga code and run it in a unit test against a real queuing system. And so you can do proper integration testing of the real saga, scheduling timeouts. One of the tricky things at that point is that you cannot really wait for your timeout to expire in 30 days. So one of the things, for example, the toolkit, the open source toolkit I built allows you to do is allows you to inject rules to reschedule timeouts. So your code doesn't change, your saga code doesn't change, and we'll try to do, for example, using the samples we showed before, we'll try to schedule the check payment timeout for 30 days, but then the testing code can intercept that and say, no, instead of 30 days, do 30 seconds, so that the test will complete and doesn't time out. There's I hope I answered that. So there's a third question that is, what if we need to reschedule a timeout? For example, invoice payment terms changed after it's been issued. That's one case. So rescheduling timeouts is not directly supported by NServiceBus sagas. It's not that complex though to build that feature by yourself. So what you can do is essentially do something like this. You schedule a timeout, and given that the timeout is just a message, what you can do is that you can add, like we did for the running total timeout message, you can add properties to that message. So one of the property you can add is an identifier, right? So you can create a globally unique identifier, set that globally unique identifier to a property of the message, and store in the saga data, so that is the state of the saga, that you schedule the message with an ID XYZ, the one identified by the global unique identifier, for a specific time, 30 days, right? Then if the message has to be rescheduled, what you can do is essentially change that value in the saga data only, saying, okay, now this message is supposed to be in 45 days. So when the message comes in as expired, your code, instead of just doing the business thing it should be doing, checks in the saga data if the time, the expiration time, still matches the one expected. And if it doesn't, instead of running the business code, it will reschedule itself. So in the sample of the 30 days, it will come in, checks, and oh, it says it's not anymore 30 days, so it's now 45. Let me reschedule myself for 15 more days. Sorry. It's a little bit trickier to reschedule something for shorter. So if from 30 days we want to move to 20 days, so what we can do is essentially create another message with a different ID and linking the two IDs, sending the message out when the first one comes in for 20 days, because it will be earlier than them. We mark that as checked, and we mark the first one as handled too in the saga data. At that point, when that comes in, if the saga is not completed yet, we can check the saga data, the list of requested timeouts, and say, okay, we don't need to handle this anymore because it was rescheduled. And given that it has been already handled, we know that it was rescheduled at an earlier time. It sounds complex, but it's not. It's just a matter of keeping track of the timeouts you request, and then knowing what to do. And it is just really a business kind of problem, because the business dictates, okay, when this happens, we want this thing to happen, and that's it. And just model that using sagas and, again, messages. So, and okay, there's a new question from Diego. If I currently, for a specific process, do not need the aggregation because I can send all the data I need for decision in the delayed message, should I build the saga anyway? Not really. So the question is related to the fact that NServiceBus has the concept of delayed messages, delayed deliveries that are not necessarily bundled to sagas. So in a regular message handler, when you receive a message and the receiver of the message, the handling code of the message is not a saga, it's just a regular message handler, you can delay a message. So you can create a new message and delay it, or delay the incoming message. That just works anyway. So you have an incoming message. Let's say that you realize that you're not ready to handle that message. You can reschedule that message for later. Let's say next week, and that you don't need a saga for that. The only use case for which you really need a saga is that if there is a state manipulation, and there might be multiple messages as multiple triggers coming in that should manipulate the same state. At that point, the saga that is built in NServiceBus is designed exactly to do that, and allows you to provides you with facilities to manipulate the same state without worrying about all the correlation problems with multiple messages coming in. It's a good implementation anyway. So if you just have one single message and you want to delay that, and there's no other messages that need to be correlated, it's a perfectly valid implementation, I guess. Yes.
Looks like that's all the questions we have today. On behalf of Mauro, this is William saying goodbye for now. We'll see you at the next particular live webinar. Thank you, everyone.